Alright, this is the final video of this series, of this overview of ISIS. Like I said, this is a very high level overview. I mean, you got a good base foundation of the understanding of it. Um, so if you haven't gone through the other videos before watching this one, I would highly encourage that. That way you'll have the terminology and some of the functions of ISIS down packed as I start going through these show commands and giving you guys a better glimpse of what it looks like from a real world implementation or a testing implementation of it. So we go back to my Visio diagram here. So this is the configuration that I have set up right now. I have two iOS XR routers, and then I have a router two or three iOS XE routers that are participating in ISIS. And these are all virtualized, so definitely don't have the money to go buy an ASR 1000 or 9000 to do some testing on. So I had another video that shows what my lab is built in, so you guys can, if you wanted to do this on your own, how I did it using VMware, ESXi, and vCenter, and tie that all together with my GNS3 to be able to do a lot of the topologies that I'm running on. So another thing you'll probably see is as I do my show interfaces, this is actually the large portion of what the configuration looks like. And what I did is I just took a portion of the network and made it a piece for studying and practical purposes. So a lot of the interconnecting links that you'll see configured on the routers will not actually exist anymore. Well, they exist, but they're just not being utilized. I didn't configure them to actually participate in ISIS. So this is what the logical topology is going to look like. So let's get started. So on router 6, one of the things I was explaining before is that the multi-area support, just so you guys can see what I was saying. So router 6, it's actually configured with two areas, or two nets. It has one net containing area 0 and one net containing area 2. So if I go there, and you can see that's actually configured here under the global process. It's pretty easy to configure. You just go into the router, configure router ISIS, you give it a name, or you can use a number, whichever you prefer, and then you configure your nets. So you can have multiple nets. I don't know what the limitation is, but I know you can have more than one. So right now 6 has 2, and underneath each interface, so it's 1.56, which is going between router 5 and 6. As you can see, I got that configured as a circuit type level 1. And then under 67, which is going between 6 and 7, that's also a level 1 circuit going between it. So all these networks are actually being advertised via the ISIS as well as my loopback address. So under router 7, we'll just do a show run section ISIS. And as you can see here, it's actually configured in area 2. And the same thing, let's just do a pipe include interface just so you guys can, we'll just do a include interface so I only can get that information and not get all the extra garble. Perfect. So these two interfaces, well, the one interface, router gigabit 1, 6 to 7 is actually configured with ISIS router type level 1 circuits, and then under the routing process, only one net is actually configured. So as we do a show ISIS database, you'll notice that within the LSP ID, you actually have the host name and then the ID of the circuit itself. So that the LSP's IDs you got for R5 and for router 5, router 6, and router 7 all have the same link state database. And if I do a show ISIS rib within the ISIS routing table, what you'll also see is the different prefixes that are coming in from the LSPs. Now, notice here the quad 0 update is coming in, and you'll see that it's coming from router 5. So router 7 that's sitting here is communicating or is able to process router 5's level 2 generated default route from its into its level 1 domain, and being able to use the get back and being able to use the default route to get out of the network. and vice versa. Let's go to router 5. So show run section ISIS. You notice, like I said, that only has area 0 configured here. And if we do a show run, right, include interface and ISIS. Router interface 56 is configured as ISIS 1, and it's using level 1 circuit type. And 1 through 5 and interface gig 1.15 is configured with a level 2 only circuit type. So if I do a show ISIS neighbor here, you actually see that R1's neighbor is a level 2 circuit, and R6 neighbor is a level 1 circuit. Now, if I made this 1, 2, you'll actually see the type L1, L2 here if it was a both, but since these are exclusively one and the other, um, ISIS will only keep adjacencies for that respective level. So if I do a show ISIS rib, show ISIS rib, you'll notice that the actual routes that it received from the other routing domains, now you have level 1 and level 2 routes. Because I have the level 2 adjacency, router 1 is actually passing all its routes that it knows from its database, from its level 2 database. And it'll forward it down to router 5, who will actually keep a full topology. So if I do a show IP route, you'll notice that router 5 will have level 2 and level 1 learn routes. Router 7 should only have level 1 routes with the default route that's coming from router 5. So, and then we'll go to XR2, and XR2 actually resides here. So XR2's only connection is directly to R1, and the same deal if I do a show ISIS rib, show ISIS, I believe it's IPv4 route, there we go. So as you can see, the ISIS is the default route. It sends the default route that's coming from XR1. And it's got the other layer, level 1 routes that it got from router 1, which is router 1's loopback address. But if I do a show route IPv4 unicast, you'll notice that R2 only has router 1's loopback as well as the quad zeros. So if I ping 155.0.0.7 and I source it from 155.0.0.2, I have communication. I have full reachability going through it, even though router 6 and 7 or router 1 and 7 and 5 are in different areas because that link state synchronization is occurring. On the back end, I actually have a packet capture server set up. I'll show you another video later on how to do that within ESXi. So if you ever want a PCAP server to do some captures for you in line, it can actually do port mirroring, and you can actually do captures between whatever segment of the network that you want. So the capture was already done. This is just me opening up the capture. I just want to show you guys an example of what some of the messages look like. So remember, we were talking about the LAN IIHSs and then the PTP IIHSs. At one point, I had router 1 and router 5 configured as point-to-point circuits just so I can get those captures and show you guys. But essentially, let's go ahead and show you what the ISIS hello looks like. This is a LAN hello message, and I'll tell you how we'll be able to determine that. So this is a circuit type level 1 only. The system ID, which is the sender of the PDU, is going to be coming from router 7. On this segment, the system ID is actually router 7 circuit ID, meaning that he is the designated IS, as we spoke about earlier. And the interface, the area addresses that's associated with it is here. And then the IP address that's on that interface is here. So it has some pretty good helpful information. But this is what a LAN hello message looks like. And we know it's a LAN because it's the 107. So one of the things I wanted to show you guys is the difference between router 7's hello message and router 6's. So we'll filter out his guy and we'll replace that with 6. Actually, I chose the wrong field. So we'll go back here and the system ID, we'll apply this as a filter selected. We'll grab 6. So 6's hello messages are here. So the circuit type for 6 is going to be level 1, level 2. Even though I did configure it for let me make sure, yeah. Even though I did configure both interfaces for just level 1 due to the fact that it has multiple areas, it's still going to identify. Actually, no, I think I did these. Yeah, no. Actually, I'm not sure why it's showing the circuit type 1 and 2. I'll do some more research on that, but essentially that should have just been a level 1 circuit type, but beyond the fact, it shows that the sender of the PDU is router 6, the designated IS is router 7, and then one of the things that ESXi had, so ignore this here. This was an area that I had configured before, but the two that I had, area 0 and area 2, was actually showing in his hello messages. You'll notice, like in router 7, it didn't know anything about area 0 at all, but because router 6 has area 2 and area 0, it's able to process both areas from both hello packets from each neighboring device, being router 5 and then router 7. So that's what the LAN hellos look like. And another thing, so remember I was saying that ESXi uses the CLMP protocol for communication, which is based off of ISO 10589. You'll notice that there is no IP headers here. There's no layer 4, layer 3 headers related to TCP/IP. After your layer 2 and your layer 2 control header, you'll actually have your ISO protocol header, which is actually the CLMP protocol header. And beneath that, you actually have your ESXi hello messages. Now we'll go ahead and close this out and show you guys a CSNP message. And so this is the complete sequence number, which is the description of the LSPs that are coming from the that are participating within that area. So it actually tells you the sequence number, and if you do a show, so this one is actually coming from who's this guy coming from? So let me get my source. Okay, so my source is router 7 on this. So if I go to router 7 and I go do a show ISIS database, you notice the sequence number that's listed here. Those sequence numbers should actually be contained in that CSNP packet, which it was. So you'll notice we have the sequence number 044, or actually, this might be an older capture. It should have this might have changed recently, but essentially this sequence number is going to match up with the link state database. These are old captures that I've done. I can do some new ones, but don't really have time. So these are actually the sequence numbers that should match up with the link state database. Then, if we go a little further, another message type that I want to find is an LSP message. Here we go. And so we'll pull this open. And this is for, I don't want that. That's not the one I want because that is referencing an EIS. Okay, this is what I want. Okay, so this is a link state message that actually gives you the area addresses and the IS reachability. This is what I want here. So from here, it actually tells you the prefixes that are coming in and the default metrics that are associated with each prefix. So you got router 5 and then the connection between router 6 and 5 that it added into its RIB for prefixes. So that's some information that you can actually grab from the actual flooded LSP. So what we'll also do now is go ahead and open a ISIS message that contains a point-to-point hello message. So Wireshark is intelligent enough to know that this is a point-to-point hello message. But the way that you can tell if you don't have Wireshark or you're doing some kind of TCP dump and you're having another packet analyzer, like I said, you go into the, where is it at? the local circuit ID. So that local circuit ID, remember, it's equal to 0. If it was a LAN, it would be equal to the circuit ID of the DIS. So this kind of gives you guys an overview on how this looks like from a packet capture perspective. Once again, you'll notice there's no IP headers associated with this at all. This is all going to be CLNP, CLNS related traffic. But you have a good overview on what ISIS is and how it operates. And if you have any questions, feel free to leave a comment. Give me any tips. Correct me if I said anything incorrectly. Definitely do not mind the criticism. Everybody needs that from time to time to get better, especially with this stuff. It's so much information. You might oversight or overspeak or underspeak on a topic. So if anybody else catches anything, um, definitely let me know so we can make sure that people are getting the right information. But until next time, see you later.